First, I need to let you know that there are no scheduled fire alarm trials. So if the fire alarm goes off, please make your way orderly to the exits there or the exits up there, and phones on silent, please. Okay. I have to say all that, okay? So anyway, I really am absolutely delighted. I don't just write this, or someone else doesn't write. I really am delighted to be here to welcome and introduce to you Professor Scott Barrett, to both the online audience and our audience here in the Sheikh Zayed Theatre today. So Professor Barrett is the Lenfest Earth Institute Professor of Natural Resource Economics at Columbia University in New York City. That's a long title.
Yeah.
With appointments in the School of International Public Affairs and the Earth Institute. We're also, of course, particularly pleased that he's currently our LSE Centennial Visiting Professor here at the school. So Scott is an absolute leading scholar on transnational and global challenges, and he addresses a broad range of issues, including climate change, that very soon you're going to hear a lot more about, ocean governance and disease eradication, amongst other topics. He's also played many leading roles in the policy arena. He's been advising international organizations such as the UN, the World Bank, OECD, European Commission, senior lead advisor to the International Task Force on Global Public Goods, and a lead author of the IPCC, and a member of the WHO Strategic Advisory Group on Malaria Eradication. He's also, of course, accumulated many awards during his career, the Eric Kempe Prize by the European Association of Environmental and Resource Economists, and Publication of Enduring Quality Award by the Association of Environmental and Resource Economists, who also made him a fellow of the organization in 2019. But obviously, he might just feel his greatest achievement was it being awarded a PhD here at LSE. So I think we'll take that one. Here indeed. So anyway, the title of Scott's talk this evening is Climate Change Diplomacy, a Most Dangerous Game. And by the end of this talk, if you are concentrating, you should be able to explain why, despite 30 years of diplomatic effort, global collective action on climate change has failed. You should also be able to explain how climate diplomacy can be made more effective, and we will also learn about what past and ongoing diplomatic failures imply for future climate diplomacy. For Twitter users, we have a hashtag for today's event, hashtag LSE post-COVID. The event is being recorded, and hopefully, assuming no technical difficulties, it will be available as a podcast soon after. Of course, there's going to be a chance for you to put your questions to Scott after his talk. For the online audience, please can you submit your questions via the Q&A feature at the bottom of your screen. My colleague, Dr. Faulkner, who's sat there, but you can't see him if you're online, I think. He will read out as many as we have time for questions and answers. But please let us know your name and affiliation. Same goes to people in the audience. And we are particularly keen to hear from our students and alumni. So if you have a connection to LSE, also let us know when you put your question. It'll be clear to audience members here when the Q&A starts. We'll both be sat here and looking for hands up, but I'll make that very clear. A roving mic will come to find you once I identify you as someone who it's your turn to ask a question. Please wait for the mic, otherwise people online and people watching the podcast afterwards won't be able to hear your question. I think that's enough from me. I'm delighted to hand over. Oh, I have to keep by the mic while I say this. Can't walk over and hand over. I'm delighted to hand over to Professor Scott Barrett.
Thank you very much. Thank you for that great introduction. And it's such a pleasure for me to be here at the LSE, where I did get my PhD and enjoyed myself tremendously. It's changed a bit since I was here. LSE, I did my PhD in the late 1980s, when the LSE was basically an alleyway. I was pleased to see Wright's Cafe is still around, because this is the only thing I basically recognize now. Everything has changed. It's much posher, much nicer. I hope you're as serious as you used to be, because when I was here, LSE was a pretty serious place. And we need some levity for sure, because we have to get through the day with everything that's going on, including the subject of my talk. But also we need to be serious. The world's got a lot of problems. What do we do about them? I wanted to start off, so I'm going to be talking about climate change. By the way, I have to stand here for the people who are at home on Zoom. So my tendency is to want to roam, and I'm going to try to restrain myself from doing that. So that's why I'll probably sometimes, grab hold of the podium. So I think it helps to know each other a little bit. So I know some of the people in the front here, but I don't know everyone here, thankfully. And I want to start off just by asking 3 questions. Also, by the way, you want to go into this kind of subject with some kind of reference point. So I think these 3 questions are valuable. The first question is, do you think, and if your answer is yes, you could raise your hand, okay? Do you think that climate change is an important problem that the world needs to address? Okay. Do you think the world has been trying? And finally, do you think the world has succeeded? All right, so for the people on Zoom, first of all, hello, and thank you for joining. But I can tell you what just happened. When I asked the question, do you think climate change is a problem that deserves to be addressed? I think everyone raised their hands. Not surprising at the LSE. The second question was, do you think we've been trying? I'd say maybe half the hands went up, and some of them were a bit like this, like, yeah, okay. And the final question was, have we succeeded? I didn't see a single hand come up. And I think that the answers to the first and last question, well, I would share them. I think this is a problem that requires our attention. And I think we have failed. But what I find really fascinating is that I think we've failed despite agreeing that this is a problem requiring our attention and trying. Actually, I don't think there's another issue in all of human history that has attracted as much attention and diplomatic energy in particular than climate change. So what I find fascinating is that the world convenes in many places, Glasgow fairly recently, but many places, to address this issue, trying very hard. I think that's true, and failing. Like that, I think is interesting. If they weren't trying or they didn't think it was important and they failed, you say, okay, fine. But they agreed that it's important, they have tried, and they have failed. So what I want to understand is why? Because unless we know the answer to that question, we're not going to know how to try to put things right. By the way, when I'm talking to you, I'm not interested in you agreeing with me. I'm not trying to tell you how to think. I'm not interested in that at all. I want to help you see the world more clearly. And funny enough, I think it's valuable to do that by stepping back, getting into the ivory tower, and using some techniques that I'm going to share with you that give us just glimpses of what might actually be going on. What actually is going on, we can agree on certain facts about what's going on. People meet, they have discussions, agreements are published, pledges are made. Not much happens. We can observe all of that. But what's going on behind it? Like, why is all that happening? And of course, what we're really interested in is how can we do better? So we don't even have much evidence about how to do better. How do you do better? So we have to kind of peer into the, try to look behind the curtain, as it were, to try to see what's getting on, what's actually happening. And that's what I'm going to try to, that's what I try to do in my work. And today I want to sort of piece some different, take some different pieces and pull them together and try to create an image that you hopefully will benefit from. Okay, so climate change, diplomacy, a most dangerous game. Okay. So do I have to point this in a particular direction or?
It was working earlier.
You know, it's something about me. You give me anything with a battery in it and I'm going to ruin it. I don't know. So nice to have.
Now?
Oh, yeah.
Does it work if you?
Oh, should I do it? Oh, maybe it was asleep. Okay, I can do that to people and I can do it to machines, apparently. I can put you to sleep. Okay, so the title is Climate Change Diplomacy, a Most Dangerous Game. So the first question is, why is it a game? And of course, I don't mean it's a game, that it's something that's unimportant, you know, a pastime, a distraction, but it's actually a critical issue. But it's a game because the outcome that any of us realizes depends on what everyone does, not on what any one person does. Like that's the essence of it. And this picture, the center picture of the Earth, which is a computer drawn image, I think nicely explains why this is a game. So what you're seeing there are concentrations of CO2 in the atmosphere. And where you see the red, like you hear just off of the coast of North America, you have higher concentrations of CO2. This is a glimpse at one moment in time, like today, you would see it would look something like this. And what's happening is when you release CO2, it's heavier than air and it tends to want to stay pretty much near where it was first released. But that turbulence will move those molecules around. And eventually they'll be mixed, and scientists call CO2 and most of the other greenhouse gases well-mixed gases because they tend to mix pretty evenly in the atmosphere. It's interesting in this picture that the variation in CO2 between these concentrated areas in red and the ones that have relatively less CO2, those differences are actually pretty small. The differences that really matter are not these. The differences that really matter are CO2 on average in the atmosphere over time. I'm going to show you a picture about that. That has been increasing. That's the one that matters. That's the one that shapes the climate. Okay. But what we're seeing here is emissions are being released in certain places like London, and then they're entering the atmosphere and they're spreading around more or less evenly, well mixed. And the consequences are going to be borne by everyone, everywhere, and of course for generations to come. Okay, so pretty astounding. And it's really important to understand the emissions for any particular place are irrelevant. What matters are everyone's emissions. Okay, and why is that an important point to emphasize? Because when we have climate negotiations, we don't really do that. We talk about individual countries' emissions. You know, what's Germany doing? What's the United States doing? What's Malawi doing? And that kind of thing. But actually, in a way, none of that matters. It's what everyone's doing that matters. What do we know so far? Well, we know the physics of climate change are pretty straightforward. We know concentrations have increased. That's a direct physical measure. And we have very good reason to know that that increase in CO2 in the atmosphere and other greenhouse gases have increased mean global temperature 1.1 degrees C. Mean global temperature is an index of climate change. No one experiences this at all. So when you think of climate change, it's convenient to have that as an index, but it's not what climate change really is. That's what you might call global warming, but we don't really care about global warming in that sense. What we care about are all the things that are going to be associated with that. And those things are so varied that we have trouble understanding it all. And we collapse everything into this one number. But that number is just an index. Okay. And to stabilize the climate, we have to bring net emissions, everyone knows this now because Glasgow, everyone's talking net emissions to zero. Okay. That ambition is unbelievably grand. It's audacious. It's never been done in modern human history, and markets don't want to do it. There's a lot of fossil fuel in the ground, and fossil fuels have a lot of attractions. So we need to get the entire world to move away from fossil fuels and do some other things when markets are not helping us. Okay, now, how do we do that? Okay, this is more challenging than anything we faced in the past. Nothing, I think, can compare with this. Who are the players of this game? Well, this is might be called a map of geopolitics. These are nation states, and they are the players in this game I'm going to talk about, okay? Because that's how power is distributed around the world. And there's one more player, and that's Mother Nature herself. This is interesting because we put CO2 and other things in the atmosphere. By the way, you probably know there was CO2 there before us too, before we started doing that. So CO2 is not a pollutant. People call it that. I don't know why. I don't know. They're trying to change how people see things. It exists naturally. We're just adding more of it. So the fact that it exists naturally is good because it keeps the planet warm enough for us to live. But we've been adding more, and that extra CO2 that we've added, that's what's causing the climate change that we're concerned about. So we put that in the atmosphere. That's what we're doing. That's our game. That's the one I showed you 2 slides ago. And then Mother Nature has her own game, and she's going to decide what to do with those extra CO2 molecules. In other words, she's going to decide just how much temperature is going to change, just how much precipitation is going to change, just how much extreme storms are going to change, what's going to happen on the polar ice sheets with ecosystems all over the world, all of that, human conflicts, you name it, all sorts of things are in play. And we don't know how Mother Nature is going to choose. So Mother Nature is a player, but we don't know what she's going to do. And that's really important really important to understand what the problem really is. So just think about that. When you see all these countries meeting in places like Glasgow, there's another player who's not in the room, and that's Mother Nature. Okay, the rules of the game are very important. Where do they come from? Well, the way humans are organized is that each of us is a person. Of course, you're all special, unique, wonderful, I'm sure. But we're also citizens. Very few people are actually not citizens of a state. So the way the world is organized is that each of us as an individual is a citizen of a state. States exist for our benefit to provide certain things for us, principally national public goods. So the most important, obvious national public good would be national security. And that's something we expect a state, a government, to provide for its people. Governments also do other things. For example, they would adjudicate contract disputes between parties. So they enable markets to work effectively within a country. They do many other things like this. And I'm quoting here from Thomas Hobbes: a sovereign, they can think of that as the government, is needed to keep people in awe and tie them by fear of punishment to the performance of their covenants, agreements, contracts. And what's important to understand is at the world level, we don't have a world government. There is not a global sovereign. We have instead 200 sovereign states. And basically under international law, they have a lot of freedom to choose. And that's what's playing out right now. And that has consequences. Some of them are very good, by the way, but some of them are not. So the one on climate change, generally speaking, is not. States can choose, so they can act unilaterally. They can also enter into agreements, just like people can, companies can within states. But agreements have to satisfy 3 requirements, just 3. First of all, you need to get nearly every country in the agreement. Okay, you don't need literally everyone, but you almost do, because now we're talking about net zero. So that's pretty close to that. You also need them to comply with what the treaty asks them to do. And the third thing is you need that treaty to ask them to bring net emissions to zero. Wow. Okay. Now, of those three things, getting one or two is pretty easy. Unfortunately, in this area, getting one or two out of three is of no help. You need to get 3 out of 3. Okay. So we have agreements now, like the UN Framework Convention on Climate Change, we're going to talk about in a minute. You have full participation in that agreement. You have full compliance. But the reason every country is in, and the reason they're complying fully, is that under that agreement, they don't really have to do anything. Okay. But you write an agreement that actually requires countries to do something, and then they start dropping out. Okay. Or they don't comply. So that's the trick. How do you get all three? No, I said the dangerous climate change game. So why is it dangerous? There are two ways to think about this. And I've come to these two different views from talking to I talked to a lot of climate scientists. I have a lot of colleagues in that area, but also I talked to a lot of them. One is to think about climate change, like that measure, that index I mentioned of global warming as triggering a number of changes in important geophysical systems, like the ice, the polar ice caps, the circulation of the North Atlantic, the collapse of the West Antarctic ice sheet, things like that. And this is from a perspectives piece that appeared in Nature a few years ago. I think actually it was 2019. I think that's wrong. And what they're saying is not only that you've got these different, what they call tipping elements out there, these geophysical systems that are prone to flip. So by a flip, I mean that the changes will be nonlinear. The change in temperature will be linear, but those small changes in temperature will bring about a large change in the geophysical system. Just like if you increase a temperature for, you have a block of ice and you increase the temperature above 0 degrees Celsius, it's going to start melting, right? So a very tiny change in temperature can bring about a large change in that system. And then these systems can be interconnected. So you could have melting of ice in the Arctic. That would actually cause more warming in this area, which would cause more melting in Greenland, and the two together causing slowdown of the North Atlantic circulation, which would in turn affect East Antarctica and West Antarctica, leading to more sea level rise. Okay, so that's one view about danger, is these nonlinear responses. Another view, some scientists have told me, actually they're more worried about the more linear responses. And one example of that is the effect on human mortality. So humans, we perspire when we get hot. Probably you may have done that today here in London. And our regulation depends of body temperature for our health depends on both temperature, air temperature, which we measure as dry temperature, and the moisture level. Like those two are important. And research has shown that if the what's called the wet bulb temperature gets above a certain level, humans basically cannot be active in that environment. Okay, and prolonged exposure would kill people. Okay, and what you're seeing here is these areas where these are the certain number of so-called deadly days for people living in these areas. It may be hard for you to see, but these areas mainly in yellow. And then here they get a little more pronounced, and also you're starting to see some red, and then here even more. This is for a more extreme projection of emissions. This might be kind of a midway one, and this is a history right here. So we're actually moving into a future in which certain parts of the Earth at certain times are going to be much less habitable than they are today. So that's just one example of just the linear. So both perspectives, we can't let the system progress too much. That's the critical thing. Let me just tell you about the climate negotiations, which actually happened. And this is this is my timeline. So normally when you see a timeline, it's a straight arrow, and it's, from left to right, and usually you're thinking some kind of progression or something's happening there. Well, my timeline for climate is that we've basically been like a dog chasing its tail. We've been kind of going around more or less trying to do the same thing for 30 years and somehow expecting a different result, and we're not getting one. We start here, 1988. There was a conference in Toronto. It was an informal conference, unofficial. A number of people came and experts came, and they reached an agreement, but it wasn't official. So there weren't government officials, there weren't leaders of state signing a treaty or anything like that. Nonetheless, 1988, at this conference, this first effort to basically stake out what the world should be doing, this conference agreed that the world should limit carbon dioxide emissions 20% below the 1988 level by 2005. So in 1988, this group of people, including diplomats and others, they decided what the world needs to do is limit emissions of CO2. They had a target and they had a timetable. Okay. After that, then attention turned to individual countries. What are you going to do? What's France going to do? What's Britain going to do? What's the US going to do? What's China going to do, et cetera? And at that point, countries made unilateral declarations, which, by the way, in international law, are pretty meaningless. It's a bit like you saying, I'm going to lose 5 pounds, or I'm going to stop smoking, or I'm not going to drink as much during an exam period, or something like that. I mean, I say these things all the time. I mean, I don't know about you, but and I'm sincere, by the way. I always think I'm going to do it, but I don't. Okay. Yeah, so countries make unilateral declarations, and I've been involved in this subject from the very beginning. So actually, I at one point, I think I still got it, but I haven't seen my old slides. I actually can look at the exact pledges made by individual countries going back to the late 1980s, just after this conference. Most of them were not met, by the way. Okay, and we're still in this kind of territory today, I would say. Anyway, countries said all these declarations, and then they thought, well, wait a minute. Why should my country act to deal with this problem? Because that won't have much impact unless others act similarly. So what we really need to do is get together and decide whatever we ought to do together. So treaty negotiations began around 1990, initiated by the UN General Assembly, and they led to the first climate agreement, the 1992 UN Framework Convention on Climate Change Agreement in 1992. Okay. Now, again, this is an agreement in which countries have identified the problem. They've said what all countries must do collectively, not in super precise terms at this point, but nonetheless in pretty compelling terms. I'll explain that later. And then because they weren't able to get agreement about what individual countries were going to do, they reconvened and they said, let's try again. And that led to the adoption of the Kyoto Protocol. It says 1997. That's when Kyoto was adopted, but the negotiations were not done then. That was like the headline part. And then year after year after year, those negotiations continued. And what basically happened is that the agreement that was reached initially was basically watered down over time. And they had to water it down in order to get enough countries to participate that it would enter into force. So the United States, George W. Bush, remember him? He said that the US, he would not send this treaty to the US Senate. So the US didn't participate. And when the US was not going to participate, other countries got cold feet. They had to dilute the agreement to get other countries to join. These countries did join, but there were a number of problems with the agreement. And it was clear that this was not going to be sustainable. At the same time, it was also clear that this agreement was not enough, that a lot more had to be done. This agreement was only asking about half the GDP of the world to reduce emissions 5% for 5 years. I mean, net zero, believe me, that was not even a consideration at that point. And they couldn't even do that. Okay, so they really didn't try to do very much, and they failed even at doing that. So they knew they needed to do more, and what they tried to do is basically double down on Kyoto, going into Copenhagen in 2009, because now they wanted to spread those requirements to more countries. And there were efforts to try to bolster the agreement with more kind of enforcement mechanisms, which ultimately they failed to do. And this negotiation in Copenhagen failed. You could know, by the way, this was definitely going to fail. Why? Leading up to that negotiation, there were 5 different texts that were circulating about this treaty. And you either had long texts that were to represent the interests of all countries. They were filled with brackets. That's why they were so long. In other words, they were texts that were saying, this is what we do not agree on, which was a lot. Okay. And then you had the other ones were short, but they were all about, this is what other countries should do. So they're very specific and short, but whatever else should do. Okay. So there's no agreement going to be reached. Kyoto was limiting emissions from 2008 to 2012. And the question was, what's going to happen after 2012? Well, then this other agreement was negotiated called, it wasn't really negotiated, called the Doha Amendment. This one kind of cute. It entered into force the day it ended. I'm not making this up. I mean, that's how it worked. It was basically something that was dead on arrival. It just had to be in there just to sort of tidy up and finish Kyoto, because what everyone knew in Copenhagen, because everything had collapsed here, is we had to move to a new kind of model. And the model we moved to was Paris. So probably a lot of you remember Paris more than the other ones. And in Paris, what countries agreed was that there should be a collective target. So remember Toronto conference, the 20% reduction. The collective target here was to limit concentration so as to keep mean global temperature change well below 2 degrees C, preferably closer to 1.5 degrees C. That was the collective target. Easy to get countries to agree on a collective target because everyone's responsible for meeting a collective target, meaning no one is responsible on their own for meeting a collective target. That's why they agree on this. Okay. I'm not trying to make you cynical, by the way. It's not my interest at all. I want to kind of mobilize your interest around the actual problem we're facing. And then countries were asked to make pledges for what they're going to do to contribute to the ultimate objective, to meeting the ultimate objective of the treaty. And that was a process that was encouraged again in Glasgow. So what you have here is a collective target and then individual pledges, which is what we had in 1988. So what I'm basically saying is we've more or less tried the same approach with some modifications, a little bit here and there, for 30 years, and it hasn't worked. How do I know it hasn't worked? Well, actually, technically, I can't be sure. To know whether it worked or not, you have to have the counterfactual. So you need to know what would have happened were it not for this treaty or any of these treaties. And by definition, we can't observe that kind of world because we've only lived in the world in which we had these treaties. Okay, so this is where theory and the other things I'm going to explain can be helpful. Get us to see what the world might have been like. Nonetheless, just as a way to start this, this is CO2 measured in the atmosphere. It's actually measured above Mauna Loa in Hawaii. Those measurements began in 1958. They continue now. I just printed this. I just took this off the internet the other day. So this is very fresh. So this is the physical reading of CO2 in the atmosphere, this well-mixed gas. I added this green vertical line from when the negotiations began. Now, when you look at this picture, my question for you is, do you think the negotiations made a difference? Now, technically, you can't tell because maybe without the negotiations, this curve would have gone up like this. We don't know. We can't see that. But I don't know, from a kind of a casual point of view, when I look at this, it looks to me like it didn't have much of an effect. And bear in mind, if you want to stabilize concentrations, net zero, this thing at a minimum should be flat, at a minimum. Okay. So I don't see success in this picture, despite what you often hear from people about how successful we've been. I don't know what they're talking about. And then down below, this is just the recent history. And again, you don't see, there's nothing here to feel really cheerful about. Even with this pandemic, COVID-19, even with this pandemic, emissions did fall. So they fell globally about 5 or 6%. The US emissions fell a bit more than that. So even with this pandemic, emissions fell a little bit, but when you look at concentrations, you just can't tell. I just can't see it there in the data at all. Okay. And of course, behind this reduction in emissions due to COVID, there's going to be a big increase in emissions following that's coming. Okay. So we've not been on the path we need to be on. Now, to understand the real negotiations, so these are pictures of the real negotiation. This is Paris, and this was in Copenhagen. So if you look at this picture here, this is a kind of a backroom negotiation. You got Barack Obama, President Sarkozy. This is Gordon Brown in the foreground, Angela Merkel. So you had a small group of countries trying to negotiate what to do. This is Paris, a larger group, obviously a photo opportunity. But these are the people who are negotiating these agreements. And I want to understand them. So just like the climate scientists, they want to understand the climate system. They can't embrace the entire system itself to know how it works. They can only do things like look back at history, how it worked in the past, and they can model it. They can see how in a model it would respond to certain perturbations. And more or less, that's the kind of thing we have to do if we want to understand the climate negotiations. So we're going to look at them as a game. In this game, I've got playing cards, poker chips, and beer, which is pretty much how I work. So I'm going to have some experiments I'm going to share with you with cards, some with poker chips. I'm not going to share any beer, but you can use your imagination. Okay. So here's a first game, a really super simple game. This is how I teach this in the classroom, and it's just a good starter, good way to think about this. We're going to play a game. I'm going to give each of you 2 cards. You get a black card and a red card. I'm going to ask you to hand back to me just 1 card. Now, you're going to get a payment, and it depends on which card you hand back to me and which card everyone else hands back to me. Okay? So I'm going to make this very simple. If you keep your red card, I'm going to give you €5 plus you get €1. I could just do this in pounds. I just came from Paris today. Plus you get €1 for every red card handed in by everyone else. Okay, so if this picture here I'm showing you is for 100 people. So imagine you're in a room, there are 100 people. Let's say 60 people hand in the red card. How much would those 60 people get each? They would get €1 for every red card handed in. So they would get €60. How much would the other 40 people get? They would get 65 because they would get 1 for every red card handed in, 60, and they get 5 because they kept their red card. Okay, and actually what you see, if you put payoffs here, that's the money, and you put the number of the other players that handed in their red card on the horizontal axis, and there are 100 people in total, so up to 99 can, from your perspective, you're looking at what everyone else is doing, you're deciding what I should do. This is the payoff you get if you hand in your red card, and this blue one is the payoff you get if you don't hand in your red card. So if you hand in your red card, no one else does, you just get €1 for the red card you handed in. So does everyone else get €1 from you, but they also get to, because they kept their red card, they get an extra 5, okay? So that means from someone else's perspective, if one other player contributes, you would get 5 plus 1, it would be up to 6 at this point, okay? And the spread between these two is always going to be 4 vertically, okay? And the best the room can do is if everyone hands in a red card, because if you hand in your red card, yeah, you get 1, but everyone in the room gets 1, so the whole room gains 100. And it only costs you 4, because you would have, if you kept it, you would have gotten 5. Now you only get 1 from that 1 red card. But that's why for the room, for the world, you want everyone to hand in all the red cards. So that's what we want. We want everyone to hand in all the red cards. Now, I wanted to ask you, what's this game called? Versus Dilemma. So I don't think it's normally taught this way, but this is what it is. And by the way, I think it's better to learn about these things, playing games, before anyone writes down formulas or that kind of thing. I think it's the wrong way to learn because you shut off your imagination. You don't really understand what's going on so much. What would be the prediction of game theory about how people would behave? I'm sorry? everyone keeps their red card, right? That would be the prediction. That is the Nash equilibrium. And it's right here in the solid dot. Everyone keeps the red card. Everyone then get a payoff of 5. Now, if everyone handed in the red card, everyone would get a payoff of 100. 100, my math is not always good, but 100 is a lot bigger than 5. So this is a good metaphor to understand what we're trying to do. It's not perfect, obviously, but it's a good metaphor. So when leaders meet in places like Glasgow, what they're trying to do is get countries to hand in the red card. Now, how do you think real people playing this game for real, how do you think they would play? Huh? Meaning? Well, you have to choose, the rules of the game would be you have to choose individually. But maybe what you're thinking, though, is some people will contribute and some won't. And this is actually well documented. This is from an experiment I've done with Astrid Dannenberg, referred to other work she and I have done together. But we're playing basically a similar kind of game here with 5 players, it turns out. And what you see here, the first time they play, 3 out of the 5 hand in the red card. 3 out of 5. That's pretty normal, by the way. That's about what you see. Somewhere between a half, maybe a little bit more, somewhere in that neighborhood, people will actually do the right thing in terms of our collective well-being. Okay, so they're not doing what John Nash had predicted in that first round. Now, the second round, 2 people contribute. The third round, 1 person contributes. Fourth and fifth round, no one contributes. Okay, then you start the game again. Okay, and you let them basically, regroup and try again. And then you have this phenomenon of hope over experience. So what happens is some people contribute. So now you get 2 people contributing, and then it goes to 1, and then it's 0, 0, 0. Regroup, try again. 1 person contributes, and then it drops. No one contributes. And then you say, okay, let's try one last time. At that point, they're like, I'm not even going to try. And 0 contributions every period. This is pretty typical of what you see. Okay, I think if you wanted one picture to understand the climate negotiations, this one would do pretty well. That's basically what we've been seeing. Hope, sincere, interest in doing the good job, but not actually ultimately doing it. Okay, but that's not really the climate change game, because I said climate change is dangerous. So let me change the game. Now suppose you get 10 players. Each one is going to get 10 black chips, and they're worth 10 cents each. So the black chips are cheap. Then there are 10 red chips, and they're worth €1 each. Okay, so the red chips are expensive. For metaphors, you can think of the black chips being windmills, wind turbines, or you can think of the red chips as being the more costly, the air capture machines. So these machines are taking CO2 directly out of the air. We're going to need them if we're going to get to net zero. Okay, I'll come back to that later. Now imagine that you get these 10 players. They start off with these assets here. They're going to gain 5 cents for every chip contributed. So even though the red chips are more costly, you still only get back 5 cents for contributing the red chip. And on top of that, each player loses 15 euros unless the whole room contributes at least 150 red chips, not red chips of any kind. Okay. So what's happening here is this is different from the game I showed before, because now you got this extra term here, which says that if enough chips are contributed, we're all gain 15. If we don't get past that level of at least 150, we're going to lose that 15. Okay? So how many chips do you think others, if you were playing this game, how many chips would you urge the other players, the other 9, to contribute? So everyone starts off with 20 chips. Get 10 black, they're cheap, 10 red, they're costly. If the room contributes at least 150, everyone's going to gain 15. Okay, plus you gain 5 cents for every chip contributed. But you also, your own value you take home depends on the assets you're still holding at the end of the game. So what would you urge your other players to do? Well, how many chips would you ask them to contribute? Okay, let me try again. At least 15 each. Okay, so everyone has 20. There are 10 people, so there are 200 chips that could be contributed. Okay, each chip that's contributed gains 5 cents for the room. Okay, each person in the room. So there are 10 people, so 50 cents for the room. Okay, which means that normally you wouldn't want to hand in the red chips because they're really expensive. They're worth €1, and the room is only going to gain 50 cents. So actually, it makes no sense to contribute it, except that if you contribute at least 150 in total, everyone's going to get this bonus of 15 euros, which is avoiding this threshold of 150. Okay, so the natural thing is to ask everyone to contribute 15. If you're playing this game, how much would you play? How much would you contribute? 16. Any other numbers? 10 cheap ones. If everyone else contributes 15, how much do you want to contribute? Pardon me? Yes, you put in all your blacks because they're cheap. So you definitely want to get rid of those first. But if everyone else has contributed 15, you get to determine whether the threshold is missed or not, right? So you hand in your 10 cheap ones, and then you're going to hand in 5 of the more expensive ones. So that's going to cost you €1 for the cheap ones, €5 for the expensive ones. So it's going to cost you 6. But you get back from that, because of what everyone else is doing, you get back from that 15 right away. Plus, you get 5 cents for every chip you contributed. You just contributed 15, so you get extra 75 cents. Okay, so if now this is a very different game than we played before, because now what you want to do depends a lot on what everyone else is doing and your belief about what they're doing. So if they say they're going to hand in 15, do you believe them? It turns out in this game, you have reason to believe them. So in this game, there are many Nash equilibria, not just one, unlike the other game. In particular, everyone handing in 15 would be a symmetric Nash equilibrium. Everyone handing in 0 would be a Nash equilibrium too, but it's not the only one. Like in the previous game, it was the only one. Here it's not. And that's because, we're playing with Mother Nature. And this is what, she's creating this problem of these tipping points. So what's this game called? Yes, this is a coordination game. And it's a very different game. And one of the things I want to try to explain is that people are really good at coordination, and they're really bad at voluntary cooperation. Okay, and what they've been trying to do in the climate negotiations is voluntary cooperation. So we were asking countries to do what they're bad at. And my proposal is very audacious. We should ask them to do what they're good at. Okay. Okay. Now, the thing is that Mother Nature, it's uncertain. We don't know what the threshold is. And we're not even sure what the impact is going to be of crossing it. So this is where climate science enters. As one example of that, Johan Rockström and a bunch of other scientists wrote a paper, got a lot of attention, called about planetary boundaries. I forget the exact title. And what they said is there should be a planetary boundary of 350 parts per million in the atmosphere. And where did they get that from? They said, if you look back at the historic record, when the Earth was ice-free, the Earth was ice-free when concentrations were below, basically, if concentrations were 550 or higher, the Earth was ice-free. If concentrations were 350 or lower, the Earth always had ice. So what they are saying basically is, we need to get concentrations below 350 to guarantee we keep ice in the polar regions. That's their argument, okay? So they give those numbers of 450 plus or minus 100. So between 350 and 550, but they say to avoid any chance of melting the polar ice, we should get down to 350. That's the basic essence of their idea of a planetary boundary. So that's uncertainty, that's uncertainty about the threshold. There's also uncertainty about the impact. if you just take one of these tipping points, Greenland ice, Greenland is actually the most, it's kind of a boring system in a way. It's ice sitting on land. But there are wildly different predictions about how long it would take for Greenland to melt and also how much sea level rise that would result from this. So there's uncertainty also about the impact. I've not even introduced any economics, by the way. This is just science right here so far. And the question is, does uncertainty matter? Okay, so I wrote down a little simple model to try to understand this. And what the model shows is that uncertainty about the impact, which would be instead of losing 15 euros, if not more than 150 chips are contributed, instead of that, it was uncertain. So maybe instead of 15, maybe 15 with expected value, but it could be as low as 10, it could be as high as 20, something like that. Okay, that's impact uncertainty. Threshold uncertainty would be if the tipping point isn't 150, but maybe it's something like 150 in expected value, it could be 100, it could be 200. So a little bit like the planetary boundary, okay? And what the theory says is that uncertainty about the threshold should be critical. Behavior really depends on that. And if you have certainty, you have a coordination game, which we saw before. But if you have uncertainty, you get a prisoner's dilemma, which people are not good at, which we saw before. And to test the theory, I'm going to use these ranges here that I mentioned before. So 10 to 20 for the impact, 100 to 200 for the threshold. And I did this work, all the experiments I've done is with Astrid Dannenberg of the University of Kassel and the University of Gothenburg. She's a great experimental economist. So what we found is this. If you have certainty about the threshold, that's this treatment here. So we've got 10 different groups. There are 10 people in each group. We're letting people choose those chips I mentioned before. And what the prediction is that they will coordinate to avoid catastrophe. And here what you see is 8 out of 10 groups do that, 2 don't. I'm going to come back to those 2. So the theory is almost right here. The theory says that impact uncertainty shouldn't matter at all. And here you've got impact uncertainty, but no uncertainty about the threshold. And you see that all 10 groups avoid catastrophe, which is what the theory predicts. So in general, what I've got are 18 out of 20 groups avoid catastrophe and 2 didn't. And again, I'm going to come back to those 2. The theory also says that if you have uncertainty about the threshold, cooperation should collapse because you're back into a prisoner's dilemma situation, and that's what happens here. Here, in 9 out of 10 cases, there's a 100% chance of catastrophe occurring. And in the last case, there's only maybe, I can't remember exactly what the number is, but maybe it's around 10% or so, a 90% chance of catastrophe occurring. So, and basically when we played this game, everyone experienced catastrophe. I'm so far behind where I wanted to be. This is so typical of me, by the way. I don't know why it is that I do this all the time and I spend too much time early on. Or do any other professors do this or am I the only one? And I don't get to all the stuff I want to do. Okay, so I'm going to have to speed it up a little bit. But the basic point I want to make here is that people behave pretty impeccably when the threshold is given because they're playing a coordination game. They're the same people. It's not like we changed the people. We changed the game they were playing. When they're playing the prisoner's dilemma, they do very poorly. I mentioned these 2 groups here. It turned out that there was 1 person in each group, so 2 people out of 200, who told their co-partners, the other people they were playing with, that they were going to contribute 15 and then contributed 0. So 2 rather, not nice people out of 200, which I think is a pretty good ratio for humanity. But nonetheless, that's actually what happened. And I'm sure those 2 people would have changed their mind if they could. Well, what happens if Mother Nature won't help us? So this is from the movie Dr. Strangelove. Thank you. Sorry, Dr. Strangelove. Peter Sellers, the Doomsday Machine, and he says in the movie, the Doomsday Machine is terrifying. So the Doomsday Machine basically was to prevent a nuclear attack because of the certainty of retaliation in the event of that attack. So it would be basically a suicide if you were to attack another country with a nuclear weapon. And my proposal for climate change, given what we know, is that we connect all the nuclear warheads in the world to a computer that is measuring concentrations above Mauna Loa. So we're about 420 today. So let's say that we're going to program the computer that when parts per million go to 500 in Mauna Loa, all these nuclear warheads are going to explode, and they will actually kill everyone on Earth. Okay, so now we're actually playing a climate change game that's a coordination game. There's not going to be much discussion about what to do. Countries are going to be rushing to try to act to limit concentrations to make sure we stay below 500. Okay, I'm slightly worried about those 2 out of 200 people who didn't do the right thing, but nonetheless, I'm pretty confident that the world would do well out of this. All right, let me see if I can miraculously tie together the final threads I want to make. We have one treaty that my former student, who's a professor here at the LSE, Eugenie Dugois, has worked on, called the Montreal Protocol, which is a brilliant treaty. So don't be pessimistic. Well, I don't know. Be realistic, but don't be cynical. The world has done great things, and we will do great things in the future, but we have to know how to do it. That's what this whole talk is about. This turns out, even though the intent was never to address climate change, it turns out, based on research done by Dutch scientists, that this agreement did much more than Kyoto ever aspired to achieve, even though Kyoto didn't achieve what it aspired to achieve. This agreement did 4 times as much. And the reason is the CFCs that deplete the ozone layer are also greenhouse gas. The ozone in the atmosphere itself turns out to be a greenhouse gas. When you add up everything that was changed as a result of the Montreal Protocol, you had not only protection of the stratospheric ozone layer, but also a reduction in concentrations of greenhouse gases in the atmosphere. Why did that work? It worked because it changed the game. It basically changed the game from a prisoner's dilemma to a coordination game. And it did that by introducing trade measures between parties to the treaty and non-parties. And what this does, if you look at this picture, these curves cross. We didn't see that before with the prisoner's dilemma. So what happens is if very few other countries are contributing, and you're in the agreement and very few others are, then you can't trade with the rest of the world, and that's a big penalty to you. So your payoff drops a lot. That's the red line. But if everyone else is in the agreement and you're not, then even though you can free ride, you now can't trade with the rest of the world in CFCs and products containing CFCs, and that's a big penalty. And that's why this curve comes down here. So you see the curves cross? And what that does is it creates their 2 Nash equilibria. One is that the world does nothing, but the other is that the world phases out CFCs. This is what happened. The world went here, phased out CFCs, 100% compliance. All those 3 things I said an agreement needs to do, this agreement did. Now, you might think, why don't we just do that for climate change? And now I'm gonna have to skip over some slides. A lot of slides. Unfortunately, yeah, a lot of slides. Okay. I'll wrap up verbally, I think is what I'll do. There are various ideas for how we might move forward from here. So one is from Bill Nordhaus, an economist at Yale who has a Nobel Prize because of his work on climate change. And he's proposed linking cooperation on climate to cooperation on trade. And what he finds in his analysis is that if you have a relatively low carbon tax, this is super low. The ETS price today is what, 85 euros or something? It's really quite high, I think. This is a $12.50 carbon tax, very small. And this is for a 0% tariff, 1%, all the way up to 10%, these different bars here. There are 15 regions in the world. So what happens is if you have a low carbon tax, the threat to impose tariffs would cause countries to want to join the agreement that links cooperation on climate change to trade, because countries want to avoid the tariffs, okay? But as the carbon tax increases, you'll see that the number of countries that can cooperate drops, even when the tariff gets as high as 10%. So basically, he's showing that it might be possible for us to do better by linking, but you still can't get cooperation for a carbon tax of $50 or higher. And the social cost of carbon, Simon, what's the social cost of carbon today? Come on, what's the number? 100. Okay. He's definitely going to say it's not 50. Okay. It's going to be higher than 50. We don't know what it is exactly. Simon probably knows better than most, but better than me for sure. 100 sounds good to me, not least because it's a round number. But the main point I'm trying to make here is this linkage is probably not going to do it. So but it turns out the reason this could work, this is based on other work I've done, is that this converts the problem back into a coordination game. Nordhaus didn't see it at the time, by the way, but that's what's actually going on here. I think there may be a better way to do it, and that is to break this problem up into smaller pieces. There's one, Elizabeth, you're being really patient with me. There's one other good agreement we have, which is the Kigali Amendment to the Montreal Protocol. And in this agreement, countries have decided to include hydrofluorocarbons, HFCs, in the Montreal Protocol. So they're going to phase those down. What's significant here is that the HFCs were supposed to be reduced under the Kyoto Protocol and were not. But because of the design of Kigali being very much like Montreal, I'm quite confident that this agreement will work. Okay, so this opens up the idea that maybe what we should do is look at individual sectors, individual gases, and ask, is it possible that we can address these as coordination games? And just as examples, here are some I'm looking at, and I want to be looking at when I'm at the LSE in the next couple of years. International aviation, maritime shipping, automobiles, aluminum, iron and steel, direct air capture, removing CO2 from the atmosphere, green hydrogen. These are like linchpins in a future climate world, SF6 and others, okay? Break this problem up, look for where you can convert how we address each of these through coordination. That's my basic suggestion. And the logic, I hope I've convinced you, coordination is something people do well, countries do well. Voluntary cooperation, we don't do so well. What we should do is ask countries to do what they're better at doing. This is not to replace Paris, but just like Kigali was negotiated after Paris, agreements in these sectors can be negotiated now, starting from today. And I think we can get more leverage here than just the direct approach suggested by Nordhaus. So somehow I gathered everything together, and I hope I've at least left that one impression on people. And I hope people have questions. Thanks so much.
Wow. Thank you so much, Scott. That was a fabulous presentation. I love game theory, so it was very hard to sort of encourage you to stop talking, but we've got more of your time to answer questions. And economic theory experiments and nuclear thought experiments. So, you know, what more do you need in a talk? So our roving mics at the ready. Excellent. And any questions? Okay, I want to see a few more hands. Okay, I am going to go with one there with the glasses, one at the back. You, can you see me there? Wave right at that. Yeah, you've turned around. Yep, you. And then if it's a short one, you can have number 3, Bob. Oh, I'm not, yeah, okay, so let's get the mics as quickly as possible and keep your questions short, please, because I'd like to get in as many questions as possible, and keep your answers short too, Scott.
No way. Mechanical engineering. My question is basically, interesting proposal. I really agree with the coordination thing. How do you make sure that all the sectors and all the sectoral agreements end up coalescing into effective net zero litigation?
Okay, thanks. So that was, how do you ensure that those sectors and group agreements coalesce into one larger agreement? Question at the back, and just I forgot to say, please, as you very well did, say who you are and your affiliation. Thank you.
Hi, I'm Miranda Hadfield. I work for BCG in their climate practice. My first question was similar on the sectoral agreements. Is that, are you suggesting like governments align around policies that address each of the sectors? Or is it kind of sector level organizations like the IMO, because I can see how it works in shipping, but not in the other sectors that you pointed out, maybe in aviation. And the second point was around the climate clubs that you had, Nordhaus. Is that suggesting a carbon border tax, or how does it work? Why would countries like align around a $12 carbon tax, but not $100? Can you explain the mechanism?
Thank you. So that question basically was, the second part was about climate clubs and sort of how would those work? And the first part of the question, very similar to the first, which is how would you actually design these policies? And
sorry, can I just add on one thing to the second question? Can you address carbon leakage in your response?
And carbon leakage, thank you. And have you got a mic with you there? Yep. And then after that, we'll go to Robert. Do we have some questions lined up online afterwards? Great. So we'll start with these three.
Yeah, Bob Ward from the Grantham Research Institute. Have you looked at what would happen in the coordination game when you start off with the players all having unequal positions? So, which is what happens in the climate change negotiations. So, for instance, fundamentally between the rich and the poor countries, the rich countries have more of the chips. The threshold requires them to put in more chips than the poor countries, and the poor countries lose more if there's not a reaching of the threshold. So I wondered if you'd looked at that situation.
Thank you. So that final question, if countries are unequal to start with and might be expected to have different numbers of chips and be putting in different chips. Okay, we'll go with those three to start with.
Okay, good. I have 3 hours. Is that right? Okay. So, well, thank you all. These are great questions. Really appreciate that and your interest. How to ensure they all coalesce? Well, the first thing, is if you can, the HFC agreement by itself, the slide, I couldn't run through it, but the projection is that just that agreement itself will reduce mean global temperature change by several tenths of a degree Celsius, so up to 0.4 degrees Celsius, something like that. That's significant. So even if there weren't this coalescing that you were discussing, we're going to gain from it. What I see when I look at, so what Bill Nordhaus, he's terrific, by the way, so it's not a criticism at all, but when he looks at the climate problem from the human point of view, he looks at the whole economy, which is also how these treaties are designed. What I see are systems. So for example, you have a system with the internal combustion engine and gasoline. You have jets and jet fuel. You have coal-fired power plants and coal, and so on and so forth. You have systems, not only these technology fuel systems, but also systems of systems, about how all these things interconnect. That's where I think the coalescence starts to become important. I'm kind of at early days of getting at this, but one thing I think is going to be important are two of the topics I mentioned on the list. Direct air capture, not only because we're removing CO2 directly from the air, and that's good, but also we have one of the raw materials for producing synthetic fuels. So synthetic fuels, you have to produce hydrogen. That's why I also had green hydrogen. You produce hydrogen, green hydrogen with close to zero emissions. You combine that with the CO2, you can produce hydrocarbons, which is basically a synthetic fuel, very much like the fuel we use today. You can use it with similar technology, and we would have very close to zero emissions with this. Okay, so I think these are kind of linchpins, and you can look at these individual agreements as fragments, each of which is valuable, just like the Montreal Protocol was, Kigali, etc. But then when you start to piece them together, you want to get something more. Then you need to look at these linchpins and how the different sectors kind of interrelate. Okay, so there are systems upon systems. So that's something I'm kind of at the earlier stages of thinking of. I think it was a very good question. There's a question about how do I actually imagine these negotiations proceeding? Well, I guess mainly I would say anything that works. But if you mentioned the IMO, so for shipping, so what happens is the IMO, International Maritime Organization, a specialized agency of the UN, establishes standards for shipping. It's been very successful, and I've studied in particular something called MARPOL and how it's transformed ocean pollution worldwide because it adopts a coordination game, basically. I think IMO needs to do this with climate change. Now, how would you do it? Okay, there are a lot of different ideas for how you would do it. The one that seems to look promising right now is using ammonia as a fuel for shipping. And what we'd be looking at is a new standard, which would be that you would have ammonia fuel. You have to couple that with new engine designs. And because the engines would be different and the onboard storage would be different, the ship designs would have to be different, just like they are now because of dealing with, and for oil tankers, they're already different because of the IMO. You also have to change port facilities. But once you get a critical mass of countries moving to ammonia, the others, because of the power of interconnection, are going to want to switch too. Okay, so this would be the natural thing to be negotiated through the IMO. For air travel, the ICAO equivalent, the International Civil Aviation Organization. If you look at aluminium, there obviously is an international trade association. But there I'm looking at negotiations among governments, but you also, these negotiations, totally unlike Glasgow, you would have technical people in the room, you'd have the producers in the room, and that you're looking at what is technically possible. So one thing you can do with aluminium, for example, is replace the carbon anode that's being used to produce aluminium with an inert anode. Just that one change reduces emissions, and then you would link that to trade. So the countries that are parties to the agreement would only import aluminium from countries that are parties to the agreement and therefore use the inert anode and so on. So you're creating a level playing field. This would all be done globally, and issues of equity be addressed through payments from richer to poorer countries, which you don't get in the IMO or ICAO, but I think for purposes of climate change, that would be a legitimate way forward, which partly answers Bob's question, by the way. Climate clubs, yeah, what about carbon leakage? Okay, so carbon leakage means that as one group of countries acts to limit emissions, you're basically changing comparative advantage. So what'll happen is that the greenhouse gas intensive industries in other countries will benefit from those first countries acting to limit emissions. In other words, outside the group of countries that are acting, production is going to increase and emissions are going to increase. I think this is a very serious problem. I could talk about the research that exists on this, but I think this is a very serious problem, which is why my approach is always focusing on global action and not individual nation states. I'm talking about transforming systems, totally different from the approach we've taken so far through the climate negotiations. In the Nordhaus analysis, the tariffs that are imposed have nothing to do with carbon carbon adjustments. That's totally different. So the border carbon adjustments are meant to get at leakage, which, by the way, they're going to do very poorly. One reason alone is that they don't get at leakage through the fossil fuel market. Okay, but they also have to be designed in a kind of a crude way, and it's not so clear that they're going to have much impact. Retaliation is definitely going to be an issue. Anyway, what Nordhaus is looking at is you make the threat to impose tariffs, and if that threat is credible, that threat by itself will cause countries to want to join the agreement. So the purpose of the tariffs is not to have any effect on carbon emissions directly, like a carbon border adjustment. The purpose of the tariffs is to get countries to participate in this so-called club. Okay, I actually think that logic makes complete sense. It's how the Montreal Protocol works with a trade ban. I've been advocating for this for a long, long time. I think the idea of going after the carbon border adjustments, I think is not a wise move, by the way. And also, I don't think it's wise for Europe, which said it wants to do this, to do it unilaterally. One positive thing is that Europe and the US issued a joint statement in Glasgow saying that they're going to look into iron and steel together with tariffs. Okay, that's a tiny step in the better direction, I think. I think we should be looking at this multilaterally. And then Bob's point, well, if you have asymmetric players, which of course in the world we do, we have rich and poor, big and small, et cetera. I have not done that work, but my co-author on some of these papers, Astrid Dannenberg, and her co-author on a number of papers, Alessandro Taboni, who was at the LSE, at the Grantham Institute, they did a super paper. In fact, that's how I met them, was I was asked to write a note on that paper, a super paper where they looked at that, where you had those differences. And basically, if you allow for side payments, it turns out that those differences don't matter at all. That's what they showed. Really powerful, really terrific work. And I think that side payments need to be a part of an effective agreement. Nordhaus, by the way, in his climate clubs, he rules them out. I don't think that was the right thing to do.
Great. So Robert, do we have some questions from our online audience?
We do indeed. Quite a few questions, in fact. I'm going to not read out those questions that have been answered. There was one question about the ozone regime and how can we learn from that? I think you've answered that in your talk, but perhaps you want to come back to that. But there's a question from Ariana Labassine, who asks about the UNFCCC treaty and the Paris Agreement. And she notes that they have legally binding obligations, but they don't have strong compliance mechanisms. So what role do you think could a stronger compliance mechanism play within those agreements? Could that be the answer to the problem that you've diagnosed? That's one question. Danny Torbika asks about non-state actors. Now, your talk was very state-centric, but what about all these initiatives that have sprung up from businesses, from local communities, cities, and so on? How do you rate their efforts within the global climate governance regime? Do you think they can make a difference? And if I can squeeze in a third question, there's a question from Michael Lerner, who doesn't say who he is, but I think he's a colleague of ours from the government department. And he asks, I hope that's the right Michael. Michael, if you're not the right Michael, send me a text. He asks, do cross-sector supply chain linkages make sectoral agreements more difficult or less effective, or vice versa? So do cross-sector supply chain linkages, linking them up, make sectoral agreements more difficult, less effective, or vice versa?
Well, I'll start with the last one. I don't know. So that's like an easy one for me to answer. I don't know. So I would love to talk to him. So when I'm visiting LSE,
he's in the Zoom room, so I'm afraid.
He's in the Zoom room. Okay, well, I can join Zoom. I could talk to him. I'd be delighted to talk to him. I'd like to know what he has in mind. Maybe I should be worried about something I'm not worried about. On the other two, the first one, Ariana's question about the treaties we have so far, they're legally binding. By the way, I'm glad she used that term. Legally binding? I mean, come on. People are always talking about this as if it means something. Sorry? Yeah, so yeah, so legally binding, technically it's correct. If you have a treaty, you are under customary law legally bound to fulfill your obligations, which is a bit like saying that you need to have, there needs to be, what's the word I want? Goodwill, or what's the word? Good faith. Yes, you negotiate in good faith. You can see why you have that rule. Of course you should have that rule. It's the right rule to have. But under international law, countries are free to be in a treaty or not, as they please. So if you want not to comply with the treaty, you withdraw. Okay, Canada adopted the Kyoto Protocol, ratified the Kyoto Protocol, adopted no legislation for meeting the Kyoto Protocol, was wildly out of compliance. And what did it do? It pulled out, because under international law, it's not bound by Kyoto if it withdraws. Okay, so that's how the system works. And you have to, it's legally binding. I'm not saying I'm against it, but it doesn't by itself do anything. What you have to do is create incentives within the agreement that will change behavior. Now, that was the essence of her question, though. Could you have stronger punishments? The only, boy, I could talk for a while about how they tried to involve punishments in the Kyoto Protocol. Not only was it a failure, but it was reflected no understanding, by the way, by any of these countries about how the world actually works in these situations, because they were setting it up so that countries had to punish themselves for not complying. I mean, you just don't see countries doing that. It's not going to happen. So you have to have the threats, and they have to be credible, and the punishments have to be severe. That's the difficulty. And really, that's what Nordhaus is getting at with his climate clubs. There are problems with that analysis. For example, he assumes that there's no retaliation. There will definitely be retaliation, and we've been seeing retaliation on trade measures in recent times. That's how the whole trade system works, by the way, is through the threat of retaliation. That's reciprocity. That's how the system works. So I think that there are ways we could do it. Almost certainly they would have to involve trade, but they're not solutions to the problem, not more than maybe partial. Okay, we need to do more than just that. There was a question about non-state actors. Yes, I focus on state actors, non-state actors. The reason our attention is being drawn today to non-state actors is because the state actors aren't doing anything. So everyone's turning to someone else. So people want to know what's the LSE doing? What's London doing? What's Columbia University? What's Scott Barrett doing? People ask me that. What am I doing personally about this? And so everyone's acting, the state of California and British Columbia, the province of British Columbia, et cetera, all this action. But the reason you're seeing that is because it's not being done where it should be done. Now, given that it's not being done where it should be done, it's better that it's being done some other places. I don't believe that all of this is going to be super effective, I have to say, but nonetheless, that's true. But let's not take our eyes off the main thing. This is what governments are for: supplying national public goods and negotiating agreements to supply global public goods. And I'm afraid that the alternatives that people are devoting a lot of their attention to will never be able to achieve what is needed. So I'm not against these actions by any means, don't get me wrong. It's just that they will never be sufficient. And governments have to prove their worth. They have to show that they can do a better job at this. I think what I'm trying to show is there are ways they could do better. On other issues, they have done well. We need to show that we can do well on this issue too.
Great. So what I'm going to propose is, because we have a good 7 minutes, is I know there's a lot of other questions here. And so I'm going to be equitable and give everyone in the audience who wants to ask their question here the chance to ask their question, just like people online have asked their questions. So this requires the mic holders, where are the mic runners, to safely, without injuring yourself, move rapidly. And I think we just let everyone who wants to ask a question. And Scott, if you've got time, rapid fire answers. So I'm going to give you numbers to answer the questions, okay? Number one, wave, you know your number one. Oh, you're number two. Number one, yeah, you there. I'm looking, yeah, number one. Number two, number three, number four, wave at me. Yep, number four. Any others want to ask a question? Number five. That's you, yeah, wave to me. Yep, number six, okay. Oh, and number seven. Okay, so you each have no more than 20 seconds and the runners are going to do the best. So number one, put your hand up. Number two, you'll share. Number three, put your hand up so the runners see. Okay, you all share that mic. Number four, put your hand up. That's where that mic's going. If you make your way now to there, you'll be ready. Let's go. Seven questions.
Thank you very much. Emilien Gasque from the EU delegation of the climate attaché here. I loved your lecture. Just one thing, one sentence that I had to react on. When you said the EU CBAM is not a wise move, I'd like to understand a bit better why. Two things. First, it would not be an indiscriminate taxation. We'd only ask from importers the exact same price that our producers are paying for. And secondly, we also made it clear that what happens outside would be considered. So if other countries have ambitious carbon pricing policies, and that's defined very loosely and flexibly, then we would not apply the CBAM to them. Now, where I join you is when you said that it's also helping start the debate. Last year, the UK was saying they might do a UK CBAM by 2040. Yesterday, they announced that, in fact, there will be a consultation this year on having one much faster than this. So it might be working at some level. Interesting in your views on that.
Okay, so that was a question about carbon border adjustment taxes and should we really be so pessimistic? Question two.
Hello, Katrina. I'm a sustainability chemist from Ecolab, and I was intrigued to see sulfur hexafluoride there on your list. Now, I know the power industry has tried using some alternatives to that. Do you have any further updates on how that research is going and whether it's successful?
Okay, that was a question on sulfur hexafluorides. Did I get that right? And other alternatives. Question three.
Thank you. Is it true that some countries can sell their share of carbon footprint to other countries?
Great question. Can some countries sell their share of carbon footprint to other countries? I like how that says. Question four.
Hi, I'm Modi Motsama from the Wellcome Trust. I work in the Climate Change and Health program. And my question was, how do health co-benefits or just co-benefits in general, climate action fit in within this equation, and also linked treaties like, you know, the UN Biodiversity Treaty?
Great. So how do health co-benefits fit into this? That was great. Thank you from Wellcome Trust. Questioner number 5.
Tasneem Maya, Carbon Intelligence. If you just take the example of UK, so just low national sector deals, such as the offshore wind sector deal, how long it takes to get those secured? Do we have the time to do this on a global level, sector by sector?
He said, do we actually have time to go sector by sector? Because we're running out of time, as you told us, I think, at the beginning of the meeting. We keep going round and round. Is this question 6?
Yep, exactly. Nikita Previlshikov, Political Economy Masters at LSE. Yeah, just to hammer down on Bob's point, how does Putnam two-level negotiation process work into your argument? And specifically, what is the place for post-colonial discourse? Essentially, what are the domestic constraints on actors when they're entering those agreements, right? And what is the space for talking about the history of emissions, who are the greater emitters, versus who are the emitters now?
So I didn't catch all the question, but certainly the last bit was very interesting about the fact that there are some people who've had greater historical emissions. In the beginning, you asked a specific question.
Yeah, so Putnam two-level game essentially says that depending on domestic constraints, politicians enter in international agreements. So how do domestic constraints of specific countries factor into this level of inequality between the level of commitment that various countries are able to commit?
Great. So how do we factor in the domestic constraints that individual countries are under? Question 7.
Yes, in the experiments you described, the payoff structure of the game was common knowledge among all the players. In real life, not everyone accepts the reality of man-made climate change, particularly in the United States. There's quite a substantial body of opinion that does not accept the reality of man-made climate change. Does that difference in understanding have an impact on getting these agreements to work?
Okay, so Scott, you can hate me for going against convention and firing 7 questions at you, but it was really nice. Those are brilliant questions. You got about 4 or 5 minutes just to touch on some key points that link to those questions.
Wow. Okay. What a great audience. Thank you so much. On the carbon border adjustments. All right. So first thing, you know, Europe tried this before with international air travel, right? And the other countries threaten retaliation. I think that could happen again. What I really am more bothered by with this is Europe doing this unilaterally. That's what concerns me. Now, this deal that I heard about, that I'm sure you know more about than I do, between the so-called deal. I know there is no deal, but so-called deal, the one that's being worked out between the US and EU on using carbon border adjustments or something like that. It probably won't be carbon, it'll be loosely that, okay, for iron and steel. They're going to differentiate between production processes, I believe. So they're going to look at whether you're using the electric arc furnace versus the blast furnace, that kind of thing. It's going to get very technical level. I think it's better that the US and Europe cooperate than that Europe goes alone. I don't think it's sufficient, because when you're telling other countries what they should be doing, that's what the negotiations are supposed to do. And that's the problem with this. It doesn't address I understand the frustration. I totally get it. I'm not like I'm ideologically against this at all. If it would work, I'd be in favor of it. I just worry that it's not a solution to this. But I do prefer that at least on iron and steel, it's focused, so it's not going to spill over necessarily into other areas. And I think a multilateral approach is going to be much more successful. Okay, I don't see how we're going to solve this problem without bringing in trade. I'm more in favor of the kind of approach that Nordhaus looked at, although I think there are flaws in that, as I mentioned. And I think the sector approach is a better way to go. Okay, SF6. You know, I'm trying to look through. I don't know. The answer is I don't know. I've got pages on my computer where I'm trying to get at them to try. There are some new things that are happening, but I don't know enough to answer your question. So it's a great question, though.
Within CBAM, there will be progressive, and in special sectors, aluminium and cement would be the first one where you look at. Typically, this kind of deals within the framework of CBAM. It will be very progressive, and this is total.
Okay, well, I think that would be better. Yeah, good. Okay. And SF6, I'm sorry, I totally disappoint you. All right, please do, please do. Can you sell carbon credits? Well, yes. that's the way the system was set up. I was advising the UN, by the way, going into the Rio conference in 1992 on this and how to do this. And I thought, there's no way you can enforce an agreement like this. There have been some trades. There are some that are for what are called offsets. One of the cute ones, Europe used to pay China to reduce HFCs or HCFCs. I'm getting a little confused. HFCs, I think. So they were paying. What was going on? And what was discovered that China was actually producing. I think they're producing. I'm a little twisted around here. HCFCs. They produce HFCs, and HCFCs were produced as a byproduct. In any event, they were actually creating things so they could be paid not to create them. Okay, and that was revealed. Europe did the right thing, and they said, we're not going to do this anymore. So that was correct. So there have been some trades. They're not always pretty. I believe if people did the research, they may find that Japan did some trades, possibly with Ukraine under the Kyoto Protocol. It's very hard to actually get this information, which tells you a lot. So potentially, yes, but I don't personally think that that's the way to go because it depends entirely on our ability to enforce, which we're not good at doing. The question on health co-benefits, really interesting question. When we act on the environment, we always act, we're more likely to act when human health is in jeopardy. We do this for air pollution and other areas. So I always thought, maybe we'll get more action on climate change if we could show that it kills a lot of people. Well, it turns out there's a lot of evidence now it kills a lot of people and will kill a lot of people. And we're still not seeing quite the action because that's only one side of the equation. The other is the costs, and the free riding problem is coming from the cost side, unfortunately. So I think people are drawn increasingly to concern about health, and you probably know about planetary health and all the wording around this. So I think there are those connections, and it can play a role, but on its own, it's not sufficient. And biodiversity convention, I don't think is a good agreement. So I'm not going to say anything else about it here.
2 minutes.
2 minutes. Okay. Do we have time? Oh gosh, yeah, we've got time because what's the alternative? I mean, there's no alternative. There is no quick fix for this problem. Anyone who spends time understanding this problem, there is no quick fix. We have spent 250 years increasing our emissions. This has brought us improvements in life expectancy, improved material standard of living. I could go on and on and on. The entire world, and much of the world wants more of it, not less of it. We have to transform this whole thing. Anyone who thinks we're going to do this quickly, if you look at the charts now, they're like, this is what we've been doing for 250 years, and this is what we're going to do now in the next 20 years. Well, we've been trying for 30 years and it keeps going up. I'm not saying it's going to keep going up, but we're playing a very long game. And this problem, this is our challenge, but we're not going to do it on time and we're not going to do it properly. I just want to make sure we do it. Okay, so that's where I'm coming from. And then there's the question, I guess there were a couple of questions, but the main one you were asking, I believe, was about the two-level games and we're domestic politics. What makes you think domestic politics are important for climate change? I'm just kidding. Okay, so look at the United States. Well, I don't know. It's depressing. But there's a really nice piece of work I like by Kyle Meng, who's a former student of Columbia, along with Eugenie. And Kyle looked at the effect of lobbying on the probability of passage of the Waxman-Markey bill, which was due to be passed in 2009. And that's the kind of research we need, where basically what he showed was that actually the pro Waxman-Markey people contributed more in total, but the dollar for dollar, the anti Waxman-Markey and fossil fuel money was more effective. Now they don't know why that is, but that's the kind of research we need. But I would say that solving the domestic problem, because you don't have a domestic dysfunction everywhere on the planet and you're not getting action on climate change. So I think it's necessary, but not sufficient. Okay, so we need to do both. And the last question, payoffs, common knowledge. Yes, absolutely. I was assuming that. Not everyone accepts the climate change as a problem. My goodness, it's amazing what people believe. And it used to be seeing was believing. and now believing is seeing. So in other words, I believe something, and therefore when I look around, everything I see confirms what I see, believe about the world. How do you address climate change with that? Well, not easily. I actually think as difficult as climate change has been, it's more difficult now because you don't have this kind of trust. You don't have this kind of cohesion. We don't have the institutions we can rely on, like democracy, even a belief in multilateralism. All these things have been in jeopardy. And as difficult as it has been to deal with climate change up to this point, I think it's even more challenging. And unless we get those fundamental things straightened out, it's going to be very, very hard to get action on climate change.
Well, with that,
Sorry, I didn't mean to end on a negative note.
That was not how you were supposed to end, but never mind. We'll take that as a call to action. It's been clearly a great pleasure for me, and I think a great pleasure for everyone. Thank you to the audience in this room. Thank you to the online audience. Thank you to the questions. It's just been a privilege to listen to Professor Scott Barrett. And we're really grateful that, you could find time in your busy schedule. We're going to take more of your time, you know that. Big round of applause.